Welcome my dear friends. Now in this session we are going to solve our 2018 and that will be your question number 2. Okay. So let's start our session. First of all you have to consider your question. A standard vapor compression refrigeration cycle. That means your BC cycle is given. Okay. Your BC cycle is given first of all. Okay na? Over which scale? Over P and H scale. pH scale. Okay, over pH scale your BC cycle is given, that is your H scale and that is your pressure scale. Okay, operating with an condensing temperature of 35 degrees centigrade, that means this condenser temperature is nothing but your 35 degrees centigrade. Okay, and the evaporator temperature is minus 10 degrees centigrade. Evaporator temperature is minus 10 degrees centigrade. Developed 15 kilowatt of cooling. Okay, 15 kilowatt की cooling develop की जा रही है. That means your refrigeration capacity is nothing but your 15 kilowatt. Is it all right? Okay. The pH diagram shows as enthalpy of various state. Various state की enthalpy, that means at that point, at that point, at that point. Various point की आपको enthalpy given है as per question. Okay, as per question, that means suppose that this will be your point number 4, this will be your point number 1, this will be your point number 2, this will be your point number 3. That means S3 is equal to H4 is equal to 250. S3 is equal to H4 equal to 250. What? 250 kilojoule per kg. This enthalpy is given. Also here your pressure, that means P3 is equal to P2 is given as 650 kilopascal, and here P4 is equal to P1 is given as 400. That means P1 is equal to P4 is given as 400 kilopascal, and also your H1 enthalpy is given. H1 enthalpy is given of what? 400 kilojoule per kg as per diagram, and your S2 enthalpy is given as 475 kilojoule per kg. So these are the given values. Okay, various stage. After that, if the isentropic efficiency of the compressor is 0.75, that means that is your compressor work, that means input. Okay, and that will be your compressor work. Okay, so isentropic efficiency for your compressor is nothing but your what? Your 0.75. 0.75 आपको compressor given है उसकी isentropic efficiency, that means what? 0.75. so as per this isentropic efficiency of the compressor, you can write your formula that work isentropically work isentropically upon work actual. You can easily write it. Okay, you can easily write it, this equation. And after that, the magnitude of compressor power in kilowatt you have to find. इस क्वेश्चन के लिए आपको क्या फाइंड करना है? इस क्वेश्चन के लिए आपको फाइंड करना है व्हाट? पी मैग्नीट्यूड आपको फाइंड करना है कि पी मैग्नीट्यूड कितना होगा फॉर योर कंप्रेसर. ये चीज आपको फाइंड करना है एंड दिस विल बी योर गिवन डेटा. आफ्टर दैट, now let's proceed with solution. Okay, very good. So these are the your given values, and after that you have to proceed with solution. So first of all you have to make a space. सबसे पहले आप स्पेस को जनरेट करिए. ओके, वेरी गुड, दैट विल बी योर स्पेस. अब हम प्रोसीड कर रहे हैं सॉल्यूशन की तरफ. इज इट? अब हम स्टेप बाय स्टेप सॉल्यूशन की तरफ प्रोसीड करेंगे. दिस इज आवर फर्स्ट सेक्शन, दिस इज आवर सेकंड सेक्शन, एंड आफ्टर दैट दीज आर द सॉल्यूशन स्पेस. ओके, यहाँ से हम सॉल्यूशन स्टार्ट करते हैं. ओके, यहाँ से हम सॉल्यूशन स्टार्ट करते हैं. यहाँ पे देखो, यू कैन अप्लाई, ये आरसी की वैल्यू गिवन है, रेफ्रिजरेशन कैपेसिटी इज गिवन, and you can write your refrigeration capacity is what? Mass flow rate and this RE effect, that means H1 minus H4 you can write easily. Okay, so as per question you can find your mass flow rate, because here your refrigeration capacity is given as 15, here 15 kilowatt, and mass flow rate is unknown, and H1 value is also known, and H4 value is also known. Okay, that means 400 minus 250, 400 minus 250. So from here this equation you can easily write your mass flow rate, and your mass flow rate is nothing but what, 0.1. After the calculation you can find at 0.1 kg per second. This will be your mass flow rate. After that you can find your work done isentropically. Isentropically you can find your work done, and your work done is nothing but your H2. This will be your compressor work na? So you can easily write that H2 minus H1. Okay, so by that, by the given data, H2 is 475, 475, and H1 value is 400. So from here you can find your isentropic work is nothing but your what, 75 kilojoule per kg. Okay, and by the using of this formula, this isentropic efficiency of the compressor, by the using of this formula you can easily find your what actual work for the compressor. So from here you can find your actual work, and this is your isentropic work upon actual work. So by the equation you can easily write that ki what, 0.75, 0.75 is just equal to what, 75 divided by W actual, W actual. So by this equation you can easily write your actual work done, and your actual work done is nothing but your what, 100 kilo, 100 kilojoule per kg. तो इस तरीके से एक्चुअल वर्क आप अब आपका निकल गया है. सो यू हैव टू राइट योर दिस इक्वेशन, दैट मीन्स पावर. पावर को फाइंड करने के लिए यू कैन इजिली राइट योर व्हाट, मास फ्लो रेट इनटू W actual. Okay, so what is the value of your mass flow rate? Mass flow rate value is 0.1, and your actual work is what, actual work is 100 kilojoule per kg is your actual work. So from here you can find your PM, that means magnitude of power for the compressor. Okay, so your magnitude for the power for the compressor is nothing but your 10 kilowatt. Okay, 10 kilowatt, and that will be your perfect answer for that question. So by this way you can easily find your questions and solution. First of all you can read, you have to read your question, mark your all the given data. After that what value gonna be find, तो जो गिवन डेटा है उनका फॉर्मूला, स्टैंडर्ड फॉर्मूला यूज कर करके आपको अननोन्स फाइंड करने हैं, उन अननोन्स को पुट करके उसके बाद आपको फाइनल फॉर्मूला लगा के आपको इजीली आंसर राइट करना है. ओके, so my dear friends, by this way you can solve any question. Okay, let's proceed with the next question. Thank you so much.